What if everything around you now is not real, and they only exist because you are there to observe it? It may sound like a philosophical question, but it is one that has puzzled humans for centuries. Now, what exactly do you mean by reality? Would you say it's the physical world we see and interact with, or is it something more abstract, such as our thoughts and emotions? Or let's define it like this. It is the totality of all things, structures, events, and phenomena that exist, whether observable or not. But this definition acknowledges that reality extends beyond the physical world that we can see and touch, and includes abstract concepts, such as thoughts, emotions, and ideas. You see how difficult it is to understand its true nature. Have you ever experienced that you've awoken from a dream, only to find out you are actually still sleeping? Dreams within dreams happen sometimes. René Descartes, one French philosopher, argued that if we cannot even tell for sure whether we are dreaming, then how can we know for certain any truth about the world in which we seem to live? His famous statement, "I think, therefore I am," comes from the realization that to think, one has to exist, and that is the only truth beyond any doubt. Chinese philosopher Chuang Tzu dreamt about being a butterfly, fluttering hither and thither, to all intents. According to Chuang, he was conscious only of his happiness as a butterfly, unaware that he was still a human being. When he finally woke up, he said, "Now I do not know whether I was then a man dreaming I was a butterfly, or whether I am now a butterfly, dreaming I am a man." Between a man and a butterfly, there is necessarily a distinction. Another great philosopher, Plato, explored these questions in his famous allegory of the cave. The allegory of the cave begins with a scene painted of a group of prisoners, who have lived chained to the wall of a dark cave their entire lives. Behind them is a walkway and a fire being set to display shadows on the wall in front of the prisoners. Every day, these people in the caves watched shadows projected on a blank wall. For them, these shadows are real and they shape their entire reality. Now, imagine that one of the prisoners leaves the cave and walks outside into the sunshine. For the first time in his life, he is exposed to sunshine and light. He can now finally see the true forms, shapes, and reality of the shadows he thought were real. In this allegory, what would he think of his companions back in the cave? He'd probably feel sorry for them and their limited reality. Now, if he returned back to the cave and told them about what he saw, they'd probably laugh at him and think he was crazy. Plato's allegory of the cave explores the tension between the imagined reality that we think is real, which we might refer to as shadows in this situation, versus the reality that is the truth, a reality outside the cave instead of shadows. Plato's allegory of the cave illustrates at least two things. First, it represents Plato's account of the nature of reality and his understanding of essence. Second, it's a lesson in what philosophy does, it reveals the true nature of things. Without doing philosophy, we remain in the dark. To sum up, Plato's cave is an allegory of the human condition. Each of us is a prisoner, chained down with a distorted illusion of reality. To gain individual autonomy, one must awaken our consciousness, we must kill our imperfections, and liberate one's senses. If the school district system were to say tomorrow that 2 + 2 = 5, and no longer 4, many will follow the new rule because they are mathematicians and they know more than we don't. Hence, what they say is true. All these people play a role in creating this false reality or shadow reality that we all perceive as true reality. We don't have individual autonomy despite the system stating that we possess such fundamental freedom. So what do we have to do? Your reality is a perception, or as the Hindus like to call it, the Maya. Your 5 senses only allow you to perceive a mere figment of reality. The 3-dimensional nature of our world limits our worldview with its duality paradigm, prevailing in all aspects of our experiences on Earth. Think about it, there are no absolute truths in this world, there are only different lenses of perception. The stars you see in the sky are in reality glimpses of your past. The colors you perceive as red, yellow, blue, and so on, are only reflections of different wavelengths of light. The average human body contains around 7 octillion atoms, and they all seemingly know exactly what to do in order to successfully perform their function. Hidden webs of information must, therefore, be guiding the atoms and molecules in their biochemical reactions, while at the same time obeying the laws of quantum physics. All this occurs within the subsystems of the cellular machinery. Consciousness might be universal, in the sense that every system might have some degree of consciousness. This view is sometimes called panpsychism. Every system is conscious, not just humans, dogs, or other animals, but even microbes. Even a photon can have some degree of consciousness. The idea is not that photons are intelligent or thinking, but maybe photons might have some element of raw, subjective feeling, some primitive precursor to consciousness. This may sound a bit kooky to you. I mean, why would anyone think such a crazy thing? The motivation comes from the idea that perhaps the most simple and powerful way to find fundamental laws connecting consciousness to physical processing is to link consciousness to information. Wherever there's information processing, there's consciousness. Where there is complex information processing, like in a human, there's complex consciousness. And where there is simple information processing, there's simple consciousness. Long before quantum physics had been developed, in the early 19th century, Arthur Schopenhauer developed his philosophy of will, which he published in a ponderous tome called The World as Will and Representation. Schopenhauer's main thesis is that the world can be divided into two pieces, will and representation. Simple enough. But for him, these had very specific meanings. Representation is how the world appears to us. That could be either the color of a flower or the spin of an electron. Will is the underlying essence of things. Schopenhauer's ideas suggest that the underlying reality of the universe is not one of essential determinism but of will. And that would determine how reality is represented to us, even objective measurements like the position or momentum of a quantum particle. One interpretation of quantum physics is that this is exactly true. In quantum physics, we have the mysterious phenomenon of entanglement. In entanglement, two particles are correlated with one another, such that when you measure one it affects the other. At the most fundamental level of our existence, reality is far from being objective. Rather, it is analogous to a series of interwoven subjective experiences fed into your awareness. Experiments like the double-slit experiment and Schrödinger's cat thought experiment challenges the traditional notions of what makes up reality. The laws of quantum physics are different from the laws of the physical universe. To understand how consciousness creates reality, you have to know how particles behave at the most fundamental level of our being. Some of you may ask this question: what do physicists worship? A single theory or equation that can describe every single behavior and movement of large stellar galaxies to small and strange quantum substances, a single theory that can unify all the physical laws in our universe, a theory of everything. Over the last century, we've ripped atoms apart, eventually finding electrons and quarks, the fundamental building blocks of stuff. But are they really fundamental? Have we truly reached the bottom? Physicists like to reduce the description of the mechanics of our reality down to the simplest possible form. They expect this simplest form to have minimal parameters or moving parts. This is where the idea of string theory comes from. Some physicists believe that reality is made up of infinitesimal vibrating strings, smaller than atoms or electrons. The vibrational state of these strings is what determines the properties of the elementary particles that we observe. For example, a string vibrating at a certain frequency with a certain amount of energy gives rise to a particle called an electron. And they vibrate at countless billions of times per second in 10 dimensions of space. But why would physicists think this is the way the universe operates? To understand why, we need to step back more than 100 years. At the end of the 1800s, scientists thought they understood gravity, electricity, magnetism, heat, and gases. In 1900, Lord Kelvin apparently retorted that there is nothing new to be discovered in physics. But soon after the dawn of the 20th century, this situation began to fall apart. Einstein rewrote the very notions of space and time with his special and general theories of relativity, whilst Planck, Bohr, and Heisenberg revealed that the world of the very small obeyed the apparently nonsensical rules of quantum mechanics. By the mid-1900s, our view of the universe had been utterly revolutionized. And these new strange physical theories were yielding incredibly accurate predictions for experimental tests. The idea of string theory started in the 1960s, when physicists were trying to understand hadrons, which are composite subatomic particles made of two or more quarks held together by the strong nuclear force, similar to how molecules are held together by electromagnetic force. Hadrons include protons, neutrons, and mesons, which are composed of a quark and an antiquark. Quarks are subatomic particles that are believed to be indivisible and have no substructure. They are not static entities with a fixed position, but exist as a wave of probabilities and only manifest in a specific location when observed. During the study of the interaction between pairs of mesons, physicists noticed peculiarities in their relationship between angular momenta and masses, leading them to suggest that the quarks inside the mesons are connected by strings. These strings can be described as elastic bands made of gluons, a type of elementary particle responsible for the exchange of the strong nuclear force between quarks as they vibrate. Physicists began developing a quantum theory to explain the strong nuclear force, but this was soon replaced by quantum chromodynamics, since the string theory of the strong nuclear force described an unexpected vibrational mode that was unwanted. This unexpected mode described a hypothetical particle known as the graviton, which is the quanta of the gravitational field. However, physicists realized that there was no reason for the graviton to appear in the investigation of hadronic string, and therefore abandoned this theory. Physicists discovered in the 1970s that the mathematics of string theory could describe quantum gravity, the final piece needed to complete the theory of everything. After extensive mathematical calculations and adjustments to the hadronic string theory, scientists were able to unify all the physical laws in our universe on paper, but to do so, they had to add 22 extra dimensions on top of our 3 spatial and 1 time dimensions. This theory became known as the bosonic string theory, which was able to explain force-carrying bosons. Encouraged by this success, physicists proposed the idea of supersymmetry to bring fermions and bosons into the same theoretical framework. The principles of supersymmetry and string theory were combined to form superstring theory, which states that every boson has a fermion superpartner, and vice versa. This theory reduced the total number of dimensions required to explain the underlying nature of our reality from 26 to 10. This was the first superstring revolution, which presented 5 theories where one-dimensional quantum strings moved around in 10 dimensions of space-time. Sometimes different mathematical theories describe the same physics. This is called duality. Superstring theory is awash with dualities. There are 5 different versions of superstring theory, each representing a different type of superstring. In 1995, physicist Ed Witten developed a way to unify the many forms of superstring theory into a single framework called M-theory, which requires an additional dimension, bringing the total to 11 dimensions. Although there is no string theory in 11 dimensions, there is a supersymmetric theory of gravity known as supergravity. Supergravity includes a theory of supermembranes, which are surfaces called membranes that must be included in M-theory for it to work in 11 dimensions. According to supergravity, the one-dimensional quantum strings can stretch across different dimensions, forming membranes. These membranes exist within a hyperspace that contains universes attached to them, and together they form the multiverse. Our universe is located on one of these brands. It should be noted that M-theory is an attempt to unify the theory of general relativity, supersymmetry, and string theory. Witten explained M-theory to be the skeleton, while the 5 superstring theories to be individual bones. Our understanding of M-theory is by no means complete. Even after identifying dualities in the strings and hints of supergravity, the middle of the web remains impenetrable. Even with our current knowledge of this theory, we can predict or explain multiple phenomena that could not be explained using our best theories in physics. String theory explains why gravity is weaker than the other 3 fundamental forces. It shows that gravity permeates through different brain universes. It seeps through our brain universe into other brain universes and higher dimensions. The second thing it attempts to explain is how our universe came to be. Our best theories break down at the moment of the Big Bang. String theory gives us its own unique explanation of how universes are born. Universes are born out of brain collisions or brain separations. This is the promise of string theory. At present, the most certain experimental procedure for string theory lies at the point that is inaccessible with our current technologies. In the meantime, string theory continues to offer delightful insights to our impossible problems. Maybe the story of string theory might not be the theory of everything, but it is a useful one. As wrong or incomplete our current string theory may be, it may also be the inevitable step to point us in the right direction of understanding reality. In ancient India, there was a philosopher named Shankara who told the story about an elephant and a group of blind men. A group of blind men heard that a strange animal, called an elephant, had been brought to the town, but none of them were aware of its shape and form. Out of curiosity, they said, "We must inspect and know it by touch, of which we are capable." So, they sought it out, and when they found it they groped about it. The first person, whose hand landed on the trunk, said, "This being is like a thick snake." For another one whose hand reached its ear, it seemed like a kind of fan. As for another person, whose hand was upon its leg, said, "The elephant is a pillar like a tree trunk." The blind man who placed his hand upon its side, said that the elephant is a wall. Another who felt its tail, described it as a rope. The last felt its tusk, stating the elephant is that which is hard, smooth and like a spear. The parable has been used to illustrate a range of truths and fallacies. Broadly, the parable implies that one subjective experience can be true, but that such experience is inherently limited by its failure to account for other truths or a totality of truth. Shankara used this story to illustrate the idea that reality is not always what it seems. We may all be looking at the same thing, but our perceptions and experiences are unique to us. This means that our understanding of reality can be limited by our own perspectives and biases. According to Shankara, the only way to truly understand reality is to look beyond our own limited experiences and try to see the bigger picture. By doing so, we can gain a greater understanding of the world around us and find the truth that lies beyond our own subjective experiences. Have you ever seen The Matrix? Chances are that you have. It's a rather popular film. One of the most memorable moments in the film is when Neo is presented with the choice between the red pill and the blue pill. If he chooses the red pill, he will learn the truth about reality, no matter how difficult or painful it may be. If he chooses the blue pill, he will remain blissfully ignorant of the true nature of his existence. Neo chooses the red pill and learns that he has been living in a simulation all along. However, the concept of true reality is called into question when we consider that the red pill doesn't simply grant knowledge of reality, but rather blurs the lines between what is real and what is not. This begs the question, is Neo's present experience after taking the red pill actually real? Or could he still be inside a simulation, within another layer of reality? As we delve deeper into this idea, it becomes apparent that knowing what reality truly is, may be an impossibility. The Matrix only serves to prove that we may never be able to distinguish what is real and what is not. It's conceivable that we could be caught in an infinite cycle of simulations within simulations, each layer more complex than the last, without ever reaching any true reality. Just a simulation within a simulation within a simulation within a simulation. The idea that our universe may be nothing more than a computer-generated simulation has been a topic of philosophical debate for centuries. With the increasing power and sophistication of computing technology, it's not hard to imagine a scenario in which we have enough computational resources to simulate every single particle in the universe over the course of its history. If computing power increased to great enough levels, we could, in principle, simulate every particle in the entire universe over the course of its history. If the computer we created was a quantum computer, capable of keeping every single particle in an indeterminate quantum state, it might be able to incorporate this fundamental quantum uncertainty everything seems to possess. Maybe the simulation we live in just began seconds ago and we only think it's been 13.9 billion years, because that information was artificially included upon its creation. Maybe the universe is much smaller than we think, and all the distant galaxies, stars, and planets that we see are nothing more than simplistic representations, created by the simulation to give the illusion of a vast and expansive universe. In this scenario, the simulation would only add detail and complexity when it's needed, rather than having it be a constant and absolute property of our reality. Or maybe nothing physically exists until we are there to observe its existence. And the craziest part of it all is, maybe discovering that this is all a simulation is part of the simulation. Nick Bostrom, a Swedish philosopher, proposed in 2003 in his paper, "Are You Living in a Simulation?" That in the future, a technologically advanced civilization may be capable of creating simulations of their ancestors. These simulated individuals would possess an artificial consciousness that distinguishes them from the AI robots typically depicted in films, as their consciousness originates from a real person who lived on Earth in the past. Today, nearly 2 decades later, this concept seems increasingly plausible, especially given the current pace of progress in the field of AI. This arises a very interesting question. Let's say that the key element of a simulation is that the characters do not realize that they are in one. How do we know that the consciousness that we possess, or that voice inside our head which speaks to us, belongs to us in the first place, and not some ancient race brought around in this world again by its advanced descendants? Considering humans are almost about to habilitate another planet, just 300,000 years after our first appearance on this planet and starting from literally nothing, it is fairly credible to say that given a few more years, the advanced descendants of our race would be capable of traveling through galaxies with ease, and even create their own simulated beings, which leads us back to the very beginning and hence validating the above theory. The sole purpose of chasing this possibility and understanding the purpose of our existence is to try and understand what kind of a game we are part of to improve our chance of thriving and surviving. While the nature of consciousness, the concepts put forth by string theory, and the possibility of our existence as simulated beings all provide interesting insights into this question, there is no definitive answer yet. As humans, we experience the world through our senses and interpret this information through our consciousness. However, it is still unclear whether our perception of reality is a true representation of what actually exists, or simply a construct of our minds. The implications of this question are far-reaching, as they challenge our fundamental understanding of ourselves and the universe around us. It prompts us to ask questions about the nature of existence, our purpose in life, and our place in the grand scheme of things. In the end, it is up to each individual to grapple with this question and come to their own conclusions. Whether we are living in a simulated reality, a multiverse, or the only reality that exists, one thing is certain. The pursuit of knowledge and understanding of the universe around us will continue to push the boundaries of what we consider to be reality. In one of my previous videos about this topic, I talked more about how important it is to understand that we're not seeing reality. Instead, we're seeing a story that's being created for us by our broken brains. You can watch it by clicking the video up on your screen. Thanks for watching, and subscribe for more videos.